Hello everyone, welcome to chapter 15 of the Java tutorial, which is about working with files. So far, the only way to interact with our program was basically using the keyboard to enter numbers or text, or to print some string to the console using the system_out_println method. But of course, often we have input data which is stored in files which our program should read, and also maybe we have some output data which we should or would like to write to an output file. And precisely that's what I'm going to present today. Okay, so print line, that's actually nice. Here we can call this method for our object system_out. So we have this object system_out, and we use this instance method println now to ask this object, please print a string hello world. And if we look carefully in the Java documentation, then basically we see that this method println, that is actually an instance method defined in the class printStream. So meaning we can call this method for any object of type printStream. And well, system_out is such an object. It is an object of type printStream, which is representing the output to the console. So why am I talking about this println method? Well, the nice thing is that we can call this method also for other print streams, namely for print streams that are representing the output not to the console, but to a text file. And that's how we can write data to a file. So let's look at this example. We could create a print stream O representing the output stream to a file, and then all what we need is to call o.println hello world. So dear object O, dear print stream O, please print this text. And the print stream will then, if it's a print stream representing the output stream to a file, will then write this text to the corresponding file. Well, and of course, then the main question that is remaining is, how do we create such a print stream O, which is representing the output stream to a file? And the answer is, we just need a suitable constructor for this class printStream, which is instantiating such an object, meaning an object representing a stream to an output file. So now that's actually the first time here in this tutorial that I'm showing a screenshot from the Java documentation. But actually it's quite important to work with this documentation because, well, if you would like to know all the, let's say, math functions that are available in the Java class math, something like sqrt or sine or cosine function, then you need to look up here in the Java documentation how these functions, how these methods are called. And now here, this is not the class math, but it's the class printStream that I have opened here, or which I have here documented in this HTML document. So you see, first of all, class printStream here, and if you then scroll down, you see there are multiple constructors for this class available. And in particular, there is this method, this constructor, printStream, which is requiring as an argument the name of a file as a string. So all what you need to do is you need to provide this constructor with a file name, and this constructor will create then an output stream to that file that you specified here with the name. And then you can use that printStream object, let's call it O, to call o.println and in round brackets some text, which is then written to the file you have specified here with its name. Well, we can do exactly that, and you see it's actually very straightforward to write data, text data I should say, to a file. What we do here is, well, as I said, we create a new object of type printStream using the constructor that we have just found in the documentation. This constructor just requires a file name. Let's call this name maybe output.txt, because it will be a text file. And then we can call o.println, hello Welt, meaning hello world, and this string is then written to the file. What we need to do then at the end is, however, because we have opened this output stream to a file, we also need to say o.close to terminate all the outputs, actually to execute all pending outputs and to close the file. And with that, the file has been generated here with this single line of text, Hallo Welt. So that is actually nice. Instead of having system out here, we call the method println for the printStream object O that we have created with this constructor. Unfortunately, however, well, if we do something like that, we may have a compile error. And basically what the compiler is complaining about, you can see here in this error message. So the compiler says there is in line 5 of our code, so here when we create this printStream object, there we did something wrong. Namely, well, there is actually here the information that this constructor, it may throw an exception, namely a file not found exception. And well, this exception is an exception that we must not ignore. So the compiler requires us to handle this exception. Well, and I'm not going into the details here about how to handle exceptions. That would be a chapter on its own. But what I can say here is just that, okay, the easiest way to handle such exceptions is just to say, well, we simply in our code here, we simply highlight that this main method may throw an exception. So in case that here this constructor runs into an exception, this exception is basically thrown by the main method. Yeah, so I think we need to take this for granted now. This is the easiest solution to this problem, but with that minor fix, this program is running already. So meaning the program will open this printStream to the file output.txt. If the file does not exist, then this file will be created. Then the hello Welt string is printed to that printStream, or rather to the file. Finally, we execute all pending outputs and close the file. And you see here what is happening if we compile the program and run the program. We don't see anything here on the console, but we will see then that there is this file output.txt in our project folder. It has been generated, and within that folder we will find this one line of text, Hallo Welt. There it is. Yeah, so here I open this file output.txt in the text editor. Okay, writing to a text file is quite easy. Reading from a text file is still easy, but a little bit more complicated, I should say. So again, what we use here is the scanner class. We have used that class before to read from the keyboard. Yeah, so just remember the scanner class, it has a constructor that requires some object. Here we used this object system_in representing the keyboard. And once we have created this scanner object, we can then retrieve the next input from this scanner, and this next input is then assigned here into this variable input of type string. And well, expecting maybe a double number as input, well, we would first need to pass that string input to a double number with the class method passDouble defined in the Java class double. And with that, we have maybe read now the x-coordinate of some point object from the keyboard. Yeah, just to look again here into the Java documentation, you will see the constructor that we use here actually, that is documented here. So that is this scanner constructor, which requires an object of type input stream as input. And basically this object system_in is such an object. It is an object of this type input stream, and in particular it is the input stream representing the keyboard of the computer. So now we would like to change our example in such a way that we are not reading from the keyboard anymore, but instead we are reading now from an input file, input.txt. And what we are doing here, you see there is another constructor here in this class scanner. And basically that is the one we are going to use now. So this other constructor, it requires an object of type file. That's an object we first of all need to create, but that is not so difficult because the class file has a constructor that requires just the file name as a string as input. So what we can do here is we take this constructor of the class file, we provide it with the name of the file, and calling that constructor will create a new object of type file, which we here refer to with f. And now that we have created this file object, we can also create this scanner object using this constructor which is highlighted here. Yeah, so that requires a file object as input. File source it is called here because it will be the source which is scanned by this scanner. Well, and now we have actually here this scanner object, and now we can deal with this as before. So it doesn't matter now that this is actually a scanner reading a file. We can just deal with it as with the scanner that was reading from the keyboard. We can just call s.next to retrieve the next string in that file, and this string is then here assigned into this string variable input, and next we are passing this string to have a double number d. That's the way how we could very easily read a double number from a file. Well, just to put this into the right context, here we have the complete program now, including the method head of the public static void main method. We have then these lines of code. Again, additionally, I'm using here this system out println method to report then the value that we have read from the file, just for testing so that we can see whether our program has actually correctly read the double number. And also here, when opening a file for reading, also I need to take care that our main method is handling this exception that this constructor of the class file may throw. And we do this again in the most easy way, that we simply say our main method may throw an exception. That means we are not handling it in any way. We are just saying this main method may throw an exception. So for example, if we try to open a file which does not exist, so then our main method will throw this exception. Well, you see that this example requires some imports here because, for example, the class file, it's actually defined in a package IO, which stands for input-output. That is not core Java, so we kind of need to import that class to use it here in our example. And similarly, we need to import this scanner class, which is defined in the package java.util. So standing for utility classes. And what is happening now if we compile and run the program is, well, suppose we have such an input file lying in our project folder, then this main method will actually create this file object, it will create the scanner object, it will then read the next string from that file, which is a string of 5 characters, namely 0.034. Then with pass double, this 5-character string is converted to a double number. And then finally, that double number is reported to the output. And that's precisely here the output that you see. D is equal to 0.034. So basically the program does nothing else than reading a value from a file and printing it then to the console. Let's do a little bit of a more interesting example here. We're not just interested in reading a single number usually. So our input files, if you think of geoinformation, usually these input files, they contain many geometric objects with coordinates, and so that is quite common to work with in the GIS context. And in particular, there is a format called WKT, which stands for well-known text. So what you see here, those are 3 representations of line strings in the well-known text format. So line strings, that's often also called a polyline, meaning a polygonal line with multiple vertices. In this example here, each of these line strings has just 2 vertices, namely the first one here, 30.1, 10.1, that is the start vertex, and the second coordinate pair here, 10.1, 30.1, that's the end vertex. So basically it's a line segment. It's a special line string, namely a line string with only 2 vertices. That's called a line string. No, sorry, it's called a line segment. A line string could have an arbitrary number of vertices. So that is something we would like to read in with our program. And then we would like to return the length of every line segment. So for all these 3 line segments, we would like to compute the length and print it to the console. So that is our task. So what we do here, first of all, well, let's first of all think of how we would solve this task if we were given already this string S in this form. So that could be one line of our input file. But to make the problem easier, let's assume that we have this string already. So we are not dealing with the input file here. We have this input string already, representing one line from our file. Well, and now, of course, we need to kind of chunk this string into meaningful pieces. And in particular, we are interested in these coordinates 1, 2, 3, 4. So what we need to do here is that we need to say, okay, what are the symbols that we use to delimit these interesting parts of my string, the string delimiters? And I'm saying it's the opening round bracket, the closing round bracket, the comma, and the space. So these 4 symbols, they are kind of decoration, and they are delimiting the chunks of my string which I'm going to consider separately. And basically, if these are the delimiters of my string, then I have the first part of my string is simply line string, the second part is 30.1, the third part is 10.1, the fourth part is 10.1, and the last part is 30.1. So basically, by defining these delimiters, I'm saying these 4 characters are used just for decoration and for delimiting the interesting pieces, the interesting chunks of my string. So, and now I'm using an object of the class string Tokenizer. So this string Tokenizer is now used to actually chunk this string into these meaningful pieces and to provide me with one of these pieces or tokens one by one. You see here in the example how that works. I create this string Tokenizer object from our string S and the string of delimiters, namely this. Yeah, so I'm using this constructor of my class string Tokenizer, and now I have created this string Tokenizer which can provide me now with the individual tokens of my strings, string one by one, one after another. So, token 1, yeah, that is retrieved simply calling the instance method next token for my string Tokenizer object st. And then with the next call of this instance method text next token, I will retrieve the second token, and with the next call I will retrieve the third token, and with the next call I will retrieve the fourth token, and with the next call I will retrieve the fifth token. Yeah, so that is now, I have now basically printed these 5 tokens to the console. And what I will get then is this output. First token is line string, second token is 30.1, third token is 10.1, fourth token is 10.1, and fifth token is 30.1. So with that I have nicely partitioned my given string S into the interesting pieces, and the delimiters, they have been kind of ignored, or basically they have been understood as separators between 2 consecutive chunks of or tokens of my string. So that is now very nice, and this I can use now in a more complex example where I'm actually reading such strings as this string S from an input file. And this, well, it's basically the most complex program I would like to show here in this tutorial, but fortunately it still fits on one slide. So first of all, there are some imports that are necessary: the file class, the scanner class, and the string Tokenizer class. All these classes need to be imported first before we can use them. Then we have our public static void main method, which may throw an exception, yeah, but okay, that is just to avoid this compiler error. And then, first of all, I'm creating this file object f, assuming that the name of my input file is input.txt. And then I'm creating this scanner object s from my file. And now I'm saying here actually with a while loop while as still has a next line, meaning while I haven't reached the end of the file yet, please, dear scanner, give me the next line that you can provide. And this next line I'm then assigning here into this string variable, which I'm calling line. So now I have basically one line from my input file, and now I need to apply this string tokenizer idea that basically I am using the constructor of the class string tokenizer. Here I need to say which string is actually going to be partitioned into tokens and what are the delimiters that are there for delimiting the individual pieces of my string. And once I have now the string tokenizer object, I can now access, or let's say read, the 5 individual values or pieces of this string. Yeah? So remember this example. Each such line consists of 5 pieces, namely line string, x coordinate of first point, y coordinate of first point, x coordinate of second point, y coordinate of second point. So that we do with the string tokenizer, and with each call of next token, we retrieve the first, second, third, fourth, or fifth token of our string. Well, the first token I'm retrieving here, let's assume we know precisely the structure of this string of text. Yeah? So the first token will always be the string line string that we can just read and forget. We don't need to assign it to anything because we know that will always be line string. But now the next 4 tokens, they are more interesting. Basically, I always take the next token. That will be first of all a string. This string I can convert to a double number using the class method passDouble in the class double. And this result is then here assigned to x1, representing the x coordinate of the first point. And the same I'm doing with y1, x2, y2. So each time I'm just calling string tokenizer.nextToken, and this next token is then parsed to a double representation, and this is then assigned here into this variable. Now what I can compute next is basically I'm computing the dx, so the difference of the 2 x coordinates, and the dy, meaning the difference of the 2 y coordinates. And then I'm using the equation or the formula for the Euclidean distance. So I'm taking the square root of the sum of squares. And this is my length of the line segment, which I'm then simply reporting to the console. And that is what I would get in this example. So here I have an input file with 3 line strings. Then my program will read these 3 line strings one by one. It will chunk them into these pieces to retrieve the 4 double values. They are then used to compute the length of the line string, and then simply the length of each line string is reported here on the console with 28.28 for the first line string, 22.36 for the second line string, and 14.14 for the third line string. That's all for this example, how to read an input file with some geometry data into your Java program, to do some calculation with it, and to report the outcome of that calculation to the console. Of course, you could also write this output then to an output file. That would also be possible, as I have shown at the beginning of today's chapter. What I would also like to point out here in my example is this code does not make any assumption about the number of lines in your input file. So here we have 3 line strings, but the code would still work with hundreds or thousands of line strings. So because it just uses this while loop to iterate as long as this scanner still finds a next line. And if this is evaluated to false, meaning this instance method here of the class scanner, if that is returning false, then the while loop will terminate. You've reached the end of your input file and that's it. So then basically we terminate also here the while loop, and with that we terminate the main method, and that will terminate your program. Okay, thank you very much for attending this Java tutorial. I hope you can do a lot of this with geometry data, doing some interesting computation and calculation. Thank you and bye-bye.